Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Can you tell me how data is used in DSPy? Data inside DSPy is a kind of a module. You will dive into the details and the nitty-gritty processes in using the data. I will not be showing you how to create the data from the external data sources, but I will show you what makes the dataset in this discussion. That is the first part of the video. The second part of the video, we will dive into DSPy metrics. The data and the metrics are closely linked together. Metrics are the things that test and measure whatever you are doing. That is about metrics. So with this introduction, what I'm going to do is I'm going to start discussing about the data in DSPy. Before we dive into it, why we need DSPy examples. The data inside DSPy is expressed in form of an object called as examples. Examples are used in comparing model outputs with actual requirement. That is the first thing. Examples are used in compiling the modules and optimizing the parameters. So this is one of the important points that I want you to remember, because in the next video following this, we will be discussing how to use the optimizers. The optimizers will require some way to test whether the model is doing good or bad. Without that, you cannot actually optimize, right? Third, examples provide an automated way of measuring performance. I'll be showing this to you in this video, so stay tuned till the end. Now, this is about the why of DSPy examples. But now, what is the examples and how is the data represented inside DSPy? So there are three different types of data sets that you will come across regularly in data science, that is training, development, and test data set. And internally to the DSPy, there are three different types of information in every data. Three different type of information in every data are the example inputs. That is input, intermediate label, and final label. These are three different types of information. So you will realize this as I explain the code and also show you how the data is represented inside DSPy. In order to use DSPy effectively, you will need a couple of examples. I'll be showing you the details of HotPotQA. It's one of the curated data sets that is inside DSPy itself. I'll be showing you how to use that in the next couple of minutes. So let's dive into code execution of data module in DSPy. So for that, I'll be using we actually don't need any of the large language model connectivity for the data or the examples discussion of DSPy. I am anyway starting this currently so that I can use it with the metrics. So keep this in mind. So I am executing this step right now, and here comes the import that I have made. So the import that I am making here is the example class is getting imported from DSPy. So we are going to represent all our data in form of examples. Example object. The example object, you can give any kind of key. That is, the question here is the key and its value. So question value here is where is the moon, and the answer is in space. So this is how you create the example data point inside DSPy. Like this, you can create n number of examples, and also internal to this example, you can create n number of key value pairs. So if I am going to say an additional value like this, so if I say hint, check the science book, this is a hint that I can create, and this also can become a additional key value pair, and example will get created. So if I also, let me execute this right now, and you'll see that example got updated here. It's now having the hint. If I go ahead and if I add one more value, book, if I say book name, and if I say lost in space, I mean, you can give any book name that you want. And if I execute this, and you'll see that the additional key value pair that I created got updated in the example data point. So this is how you create a single example data point. But this is one of the usual ways you'll use, because you'll have your data in your hand in form of CSV, in form of pandas data frame, or in form of Hugging Face datasets. All of these things you will be converting it into examples. But not just that, we can actually decide which of these key value pairs are the inputs and the rest will be the labels or the outputs. So you can decide that. So for that, you can provide something called as with inputs method. So this is the example object that you have created, and if you execute this cell where I call with inputs question, then what will happen is this example will be attached with the additional information called as input keys, and that will be looking at, or that will be referencing the question key value pair, question pair. So that is how we use with inputs. This with inputs is important when you're going to work with the metrics. So this metrics and the data part of DSPy is very closely linked. So keep track of it. This video is going to be a little bit longer for explaining both the topics together. Next, I am going to create one more kind of a data set, which is going to have a doc and going to have a summary. So I have not mentioned it as summary here. I've just given a new name. Just given a part name called Suma. So this is a list that I've created. So here I can create multiple example and I can create a list, and that will become the training set. So creating the data set inside DSPy is as simple as creating lists. It's not rocket science. It doesn't have any kind of high speed internal mechanisms like arrow dataset or pandas data frame dataset. No, it's a simple list which everybody can take a look and you can see what is going on. So the enumeration happens on the list. So this is one of the cleanest way of working with DSPy. That is one of the things that I liked about this particular library. Everything can be easily understood if you know basic amount of Python. If you have read about, if you have completed Learn Python the hard way, and if you know problem solving through Python code, then most of the modules in this library you can easily understand. Okay, now we have seen how we can create the examples, how you can use the list to create train or test data sets. And here you can see, once I execute this, I can look at the inputs. So here the inputs is doc, because I have told here that the with inputs doc here. And if I look at the labels, the Suma will be the labels. So like this, you can have inputs and labels directly created for you. So you are only telling to the DSPy that I want the doc to be with inputs, meaning doc to be the inputs. The rest of the things it takes care. So for an example, if I try to add one more value, so location, you can give any value. I'm just giving a key value pair. I can say space. So I'm going to execute this. So this is going to change, add this location here. And if you look at the inputs is going to be still the docs. And if you look at the labels is going to have additional key value pair. So that's how it works. And you'll see how it is used in the evaluation and metrics in a couple of minutes. So stay tuned for that. Now, you can actually create these datasets manually, as I already told, but there is a way to use the Hugging Face datasets inside DSPy. Not all Hugging Face datasets are already coded into DSPy. HotPotQA is there, and also GSM38K, if I'm not wrong. These two datasets are there. Apart from that, rest of the datasets you have to do it manually. I am not going to discuss that process of creating datasets. If you want, you guys can leave a comment. I will look into that. But as of now, I'm going to use the HotPotQA, which is already present inside the DSPy library itself. And the second point, the HotPotQA, the complete dataset size is going to be around 600 MB. Once you initiate this this particular command in the next cell, this is going to take a bit of a time when you're going to execute it for the first time. If you're going to execute this particular cell inside the Colab notebook, it might be very fast because Colab has a very high speed internet connection. While if you're doing it in your home, this is going to take a considerable amount of time. Even if you have 10 Mbps or 15 Mbps, 30 Mbps connection, it's still going to take at least 5 to 10 minutes. So give it time, it will work. After that, you will be able to, you will get this particular output. So this just says that it is a Python class. Okay, how to use this? In order to use this, in order to use the data that is inside the HPQA or the HotPotQA object, all you need to do is look at the train and test data parts. So HPQA, and if I call train, so you'll see that I will be getting the train dataset. Train dataset, here you see it is actually a list of examples and it contains questions and answers. And if you go a little bit this side, the input keys are none. If you have to use this dataset for training or testing purposes inside DSPy, you need to have this input key set. So for that, there is a process that we will look next. Clear cell outputs, and here we are going to see only one train example point. So you can see the example point here. I'm printing, the print is little different here because I'm using the print function from rich module. Okay, so I have introduced data in DSPy. That's all. It's as simple as that. As I told you already, I am not diving into the creation of new data sets. Try to take a look at the tutorials and documentation in DSPy. It's pretty straightforward. Moving forward, now comes the DSPy metrics. Metrics range from simple, intermediate, and advanced functions that can evaluate data returned by the modules. The modules that we are talking about here are those classes or objects in DSPy that connects with the large language model like GPT, ChatGPT 3.5, GPT 3.5 Turbo, GPT 4 Turbo, whatever you call it. It connects to that, and the metrics will evaluate the data that is returned by that particular model. So why metrics? In order to check whether the model prompt module is of any use. So you might actually, write a super prompt, and you would have learned, you would be a world's greatest prompt engineer, and you are pretty sure that whatever prompt you have written is going to work, and it works. Yes, you are really happy. But then once you start changing the context, then you see that your prompt starts falling apart. You then get a little bit agitated, and then you start tweaking the prompt. So it works for a couple of more contexts, and then again it starts falling apart. This is the regular prompt engineering process. You are manually optimizing the prompts. You are doing manual work, which is foolish. Honestly, with computers, with the power of large language models, you have to make the computers work for you. Metrics can help you do that, because metrics are going to be the eyes for you, be the ears for you. In any computer program, whether it is Python, whether it is C, whatever language you are learning, there is a concept that the programs don't have eyes or ears. You have to give them eyes or ears using the logic. Metrics are the ways to give logic and make the program itself to test the logic by itself. So that's the quintessential part of having metrics. So you will be wondering that metrics will be, way more complex and all difficult stuff. Believe me, it's direct and straightforward. So let us dive into the metrics right now. The DSPy library themselves have a couple of simple functions implemented. You can take a look. You can use these functions also. You can take a look at that. You can use, I'm going to execute this. You can use the internal inspect module, or you can just press F12 in VS Code if you are. And you can take a look at the logic here of the answer exact, answer passage match, etc. So that will be under metrics. Anyway, going back to the discussion, I've imported a lot of stuff here. So I'll be showing you one by one what I've done next. So let me execute this. Here, there are three metrics that I'll be using. So one is a simple metrics, one is a little bit intermediate metric, and then third is the advanced metric. The simple metric does only one thing. It takes the examples, it looks at the answer of the example, and then it checks whether it is same as the predicted answer. If both are same, then the return value is true. If not, the return value is false. That is what the metric does. It actually takes the data, and the data, you remember that we introduced here. So it takes the answer that you saw here. So this is, if you are going to send this as an example, I'll be sending it as an example in a couple of minutes. It takes this answer, it looks at the answer that the model has provided, checks it. If it is same, then it returns true. Simple, right? And you are not going to do that. Your eyes are not going to look at the answer and check whether it is right or wrong. That's called as automation. And that's how you should do prompt engineering. In fact, you should do prompt automation. I shouldn't say engineering anymore. Moving forward. Next comes a little bit a complex step where we are going to check the context also. So in this case, what we are going to do is we are going to check whether the answer is same. The predicted answer is same as the example answer, because example is the input that we are giving. And it also checks whether the predicted answer is coming from the context. See how good it is. The answer can be still correct, but if it is not coming from the context, then it means that the model itself is actually hallucinating, or model itself knows the answer. So probably the context was not used at all. So that is also being checked. So all these things are basic logic. It's not any rocket science here. Okay, you guys may not be from Python background, but this comments that you see here, check the predicted answer comes from one of the retrieve context. The same thing has been implemented as code using this any method, any function in Python. And the pred.answer.lower is checked whether it is present in the context. And third, there is this concept of tracing. So if you are going to use it in optimizer, then you need to have this trace equal to true. At that time, it will have a different kind of calculation being done. So you see that if the answer match and context match are there, both are added and they are divided by 2 if the trace is set to none. Okay, or else the answer match and the context match is sent back. This kind of logic we can use it for working with the tracer, working with the optimizer. Sorry about that. But the logic that you are seeing here is more important. You don't need to use your eyes to look at what the model is giving out. You are going to use Python program to look at it, and it is just going to tell you whether it's true or false. No more manual work. Moving forward. Next, let us make this thing a little more complex, right? What we are going to do is we are going to get the signature. In this case, we are going to create a signature using DSPy module, and the signature is going to have assessed text, assessed question, and assessed answer. All these, out of these two, assessed text and assessed questions are the input fields, while assessed answer is the output field, and it is going to have the output as yes or no. What it is assessing, whether the quality of a tweet along a specified dimension is perfect. So that is what it is assessing. So this is how you create a simple metric based signature. How to use this metric based signature. So that's what you will see next. So in order to use this metrics based signature, we have to first of all configure this model that I have already done. And here you can see that I have used the predict assess for this particular assess underscore pred object. So keep one thing in mind. There are two objects here. So there is model underscore pred, which is used for getting the output from the GPT 3.5 model. There is assess underscore pred. Again, it is using predict only, and again it is going to use OpenAI model only. However, this assess underscore pred is going to be used for checking whether the output from model underscore pred is as per our requirement. For you see that we are using the same class that DSPy provides. Only thing that differs is the signature. So in this case, the signature for model pred is question, this divider, and the answer. In case of assess pred, the signature is going to be this one. So there are two input fields, the assessment text and assessment question, followed by the output field. So when you look at this code, it can be a tad confusing because we are using the same thing. How can this give different outputs? So the details matters a lot. Here the signature is different. So we are using assess signature here, and here we are using the string signature. The string, that is the text signature that we are there. We use that these two, and then what we start is we actually create a new metric. So this metric is going to do a lot of things. It's going to first of all get the inputs. So it's going to get the gold inputs. It's going to get the predicted data or the prediction from the model, and then it is going to assign it to internal variables here. So this is a variable unpacking that is being done, and then there is a prompt that is created internally. So there is a prompt that checks the engagement. I have just I used the terms and terminologies from the examples that I saw in the documentation, so I have not modified the variable names. So this particular prompt is the assess text self-contains, and is the assess text a self-contained information. So I am asking the model to check this. Second, I am checking whether the text should answer the question. So it should answer the question with the answer, with this particular answer. Does the assess text contain this answer? So both of these things we are going to check. And to check this, what you are going to use is, we are going to use the assess spread this particular object. So when this particular line is executed, the model is called with the generated answer and the this particular prompt. So the model is called manually. It's called to the, sorry, not manually, it's called automatically. And the same way, in order to check the engagement, whether this particular assess text is self-contained information, again the model is called with the generated answer and this particular prompt. So you see that whatever you want to check inside, whatever you want to check about the output that you are getting from the model, you can actually use the model itself to recheck it. So for an example, assume that you are working with a model that is an open source model, and you want to check the output of the open source model with the GPT 3.5 or GPT 4. It's going to be possible because all these things can be automated. Here, this particular context, you see, context, we are actually giving it as a context as GPT 3T, meaning this is going to connect with GPT 3.5. And when you're going to generate this prediction, we can use a different model, and you can do that also. You guys can take this particular notebook and try to do those modifications. And if you face any challenges, you can let me know. Using this with context, I had discussed in the earlier videos on language model. Take a look at that. So this particular metric that you are seeing here, it's a little bit complex. It is having lots of calls to the large language models, and you might be wondering, will these things work? In fact, it does work, and there are lots of examples and videos already present in DSPy about this. So I mean, if predict is going to work, obviously this is the assess predict is also going to work. It's all prompt, guys. Only thing is that you are not manually entering the prompt, and you are not testing it one by one. You are automating it, and further logic is involved here, and the score is returned out. Now what you are going to do is, we are going to put the metrics to use. So I'm going to use this HPQA train element 0. So this particular example data point is asking a question. At my window was released by which American songwriter or singer? The answer is John Townes Van Zandt. So that is the answer. And here you can see that input keys is equal to none. So I have not actually modified anything in this train dataset, train example point. I'm going to send this particular train example point, the question, to the model directly. And once I send it to the model is replying to me, it is Bob Dylan. The train dataset is telling me that the answer is John Townes Van Zandt, but the model is replying to me wrongly. Okay, so let us see whether we can check it. So if I send it through validate answer, so this is the function that we created here, the validate answer, that the most simplest metric, whether the answer are same, whether the example answer and the predicted answer are same. We know that it's not, so the answer should be false. So let us execute this, and you'll see that the reply is false. And you can send the same output to metric, and you will see that the score will be returned as 0. And in this case, this is actually calling the ChatGPT model in the backend to check this. You can use the inspect history, you can use the inspect history in DSPy models, and you can take the look at the prompts that has been sent to the models, sent to the ChatGPT models. Okay, so we have seen how the metrics work, but still we are doing it manually, right? Even though you are calling the functions, you are still calling the functions with individual data points. So you have one train 0, you have train 1, train 2, train 3. So you have to do it manually, which is not something that I really like. So what to do? What can we do to improve this? So there are two things. You can actually do this calling of calling of this metrics using a for loop, and you can send each of the train data set one by one. That is also possible. Or the other option is to use the evaluate class inside DSPy.evaluate. So this evaluate class, what it does is it takes the data set. In case of this evaluate, I'm using the DevSet, which I've created here. So here what I've done is I used the HotPotQA dev. This is one of the DevSet that HotPotQA object, that is HotPotQA object that we created at the top. So just going back to the earlier discussion on data in DSPy, we created this HotPotQA object, right? The same thing. We are using that, and we are assigning with inputs to the data points inside that. So that is what we are doing here. This is done through Python for loop, and we are doing the same thing to train set also. And then we are going to create an evaluate test object. And next what you're going to do is you can actually use this test object, the evaluate object, and then send it to a model, the model.pred. All you need to do is that only, and it will actually test all the data points. So the dev set has 5 data points. I have used only small what is it called, data points here, because I don't want to call the ChatGPT endpoint multiple times. So if you look at it, so this dev set is having 5 data points, and if you can look at the data points also, dev set execution. So if you execute this, you will have 5 points here, and all these points will have with inputs. So input keys is question, you can see that everywhere, and you can see the outputs also, gold titles. You can see the gold titles here, and what you are going to do right now is that we are going to check. Also, it has got the answer. So you can see the answers also. So all these things are present inside the dev set. I'm going to clear the cell. I'm going to execute this right now. So once I execute this, ensure that you have set the inputs the input keys using the with input method. If you don't set it, then this particular step will not work. There will be a warning telling that the inputs are not set and the answers will not be appropriate. So ensure that you do set it and then execute this. So once you execute it, it will go through the process, and yep, you are seeing it right. It actually enumerates all the 5 data points. It creates a proper data frame, shows you the questions, shows you the example answers, and also it tells what kind of output the model has given. And in case of the model that we are used, only one answer is true and rest of all are false. Yes, you are seeing it right. Even though we are using ChatGPT 3.5, we are giving proper questions and we are expecting some answers. The ChatGPT is giving different kind of outputs. Yeah, here you see there is a kind of an output, but this is not the output that we are looking for. We just want 1971, but that answer is not given. See, same here also. So there is some kind of an output, but it is not same as Danny Wallace. So when you are actually testing out the model manually, so you will get this particular line and automatically you will know it's wrong. But now it is done through the coding process. This is the process that you are going to follow from now on. It's one of the most efficient way of modifying and working with large language models. And we have not yet completed. In the next video, we are going to see how to automate this further, and we can optimize the prompts themselves. So how it is being done and what are the things that are going to impact the prompts, impact the parameters of this modules and the language models. All those things are only possible if you understand this process of evaluation, this process of how the dataset is created, how the dataset has input and labels. All these things you have to properly understand. Let me go one step further. You can also use the same evaluation process for working with vector stores also. So for working with vector stores, first of all, you need to configure the language model that is connected with connected with vector stores, and then you can create the similar kind of modules. You can give the retrieval option to the modules, and then you can send the question answer to it. So let us execute this. So I'm going to connect with Colbert v2 vector store that has been provided by the DSPy guys. I'm going to create this context spread module that is going to be a chain of thought module from DSPy. So if you guys are not familiar with these modules, take a look at my earlier video. Next, I'm going to get the context through this retrieve object. I'll be getting 2 contexts, and then I'm going to send that context along with the question to the model. I'm going to execute that, and then I'm going to look at the output. So the output will provide the rationale. It will provide the rationale, and also it will provide the answer also. So the point here is that you can use the vector store retrieval in a very crisp fashion. But whether the answer is right or wrong, how will you know that? Whether the point that we tried to check, was it perfect? For that, you can use the validate context and answer. This is a function that we wrote at the top. Here you are going to send the t data 0. T data 0 is what we have it here. Just a minute. The t data 0, we have actually changed it to train 2 here. Which of these publications was most recently published? Who put the bomb or self? And the answer is self actually. So this is what the output should have been. But if you scroll down, you will see the answer provided by the language model is wrong. It's saying self. It's actually saying who put the bomb, which is similar to self if you think about it. But we don't want this particular sentence. We want it to be mentioned as self. But the model is not able to determine that. So when I am going to send it through validate context and answer, if you execute this, you will see that the score returned is 0. So this particular idea of giving eyes and making the models and making Python to check the outputs of language models is going to make it very efficient to tune and work with large language models. So in this particular discussion, you have just to recap, we have seen how the evaluation works for both with respect to contexts and without context also. How the example data points that we create using the DSPy example class helps in this case, and how we are going to use the evaluate class in DSPy to set up the evaluator. Also, we saw how to work with different kinds of language models using the context here, and how to modify that to check whether the outputs have been how outputs match the requirement. And we can use large language models itself to make this kind of checking. So all these things we reviewed in this particular discussion. So I believe that you have learned a thing or two about not just prompt engineering. You have learned about a proper way of prompt automation. And in the next video, we will actually dive into optimizing the prompts and optimizing the modules themselves in DSPy. So stay tuned for the next video. Until the next video, have a great time and start using and understanding DSPy library and the modules. Till the next video, practice. See you guys.